You're listening to Gradient Descent, a show about making machine learning work in the real world, and I'm your host, Lucas Bewald. Sualeh Asif is the CPO and co-founder of Cursor, one of the best loved and most exciting and popular AI products out there. It helps you with coding, helps you use LLMs to do coding. I use it all the time and I really love it. And I was just excited to ask him about how he built such a great product. I found his answers super interesting and I hope you enjoy this interview. All right. Well, thanks so much for taking the time to talk. I guess maybe this is a softball question, but I was really interested in just hearing the story of Cursor, like how you started it and what the moment was where it really started to take off, because now it's like one of the most loved products I think out there.
I think that story comes from we had been really interested in sort of scaling laws, and uh, back in college, sort of I had gone on and worked on a sort of search engine type company with a friend, and there we were really bullish on language models because it felt like language models could really compress all the world's information, and there should be this end-to-end index of searching the internet instead of sort of many of the heuristics we've coded in over the years. It felt like you could sort of that should be the end-to-end way of doing things. And so scaling laws, doing the search engines, training large models at the time. I think Copilot was the first really big moment for us where like it was this project that was truly magical. It was fast. It felt like it kind of knew you. But then Copilot did not improve much over the coming year or two. And for us, when we saw GP4, for like we thought the ceiling for what a really really great product was possible at that moment was really high. And then it was like pretty clear that like as the models got much better, like scaling laws progress, models get much better. The product that can be built in the future is even higher ceiling, and that was like it was this sort of super attractive thing to go do it. And we're all sort of coders at heart, and we wanted to be building things that we use every day. And Cursor was originally built for ourselves in many ways. It was uh, and it was sort of fun seeing that everyone else really liked it. It was definitely built for ourselves. And we were sort of experimenting. So a lot of the early culture of the company was experimenting with various different ways of using the models. Should there be a document that you're sort of typing things out and the model is coding things? Should there be, what if you want to do this, next action prediction of like you're in a location, what should be the edit? Maybe the model should be telling you where to go next. You should be able to make edits over your entire repository. And some of those things have taken a year and a half, several iterations, and some of them, we've continued building on. So now, like some of the core parts of the product is this next action prediction thing, where it predicts your next edit at the cart location and then where you should be going next, and that people really really love that feature. And then we're sort of working our way towards you should just be able to make any edit you want across the entire repository, so like code base wide. Uh, and obviously there's sort of hurdles along the way that we'll talk about. Some easy, some sort of still quite difficult. Like models also struggle with what exactly the architecture of the repository is. If you ask what is the architecture of the repository, that is really quite difficult because it requires sort of looking at potentially billions of tokens, tens of billions of tokens, and saying, asking the question, what is really going on, as opposed to like, you could like list the function names, right? Like, but that doesn't really tell you, that what is exactly going on.
Well, totally. I want to dive into that as much as you're comfortable sharing, but I guess I wanted to ask you, um, one of the surprising things that I learned in my, background research on you is I think you guys came from using Vim, not VS Code. Is that right?
All of us were really early users of Wim. We did eventually, had used VS Code. Probably the last one to. There was a couple of us. Aman and Arvid probably were the last to switch over from Wim to VS Code, and the trigger there was GitHub Copilot.
Oh, I see. So GitHub Copilot actually pulled you over, or
Uh,
in the end.
so I had switched over before, but then I think Aman and Arvid only switched over after
I
GitHub
see.
Copilot became. It was just the killer feature, right? In some ways, it was the killer feature.
Totally. And why doesn't something like Vim actually have something like what you guys built? Like it seems like a lot of smart coders, like to use it. Is there something about it, like a graphical interface that lends itself to this kind of structure, like coding with an AI?
I think for us, VS Code is, for one, it's pretty clear it's the most loved platform on the internet. Or for coders, it's the thing that sort of is the ipso facto. It's the default.
Totally.
Um, and we wanted to sort of incrementally evolve it towards the world where you're starting to automate coding. And the cursor of 1 year from now should look very different from the cursor of today, which means almost by default it should not look like exactly like VS Code. But in looking very different, you wanted to start from a place where you didn't want to have a text box to code, because coders still want to type characters, right? Uh, you want to be able to edit your entire repository at a higher level, but at some point, if you find that there's a change that you can like quickly execute in 10 keystrokes, we want to let you be able to dive into the details. At any point in time, you're maybe editing some pseudocode representation. Maybe a year from now, right? Like humans are editing a pseudocode representation, and that's really quick to edit, and the model is sort of working for you in the background. But you're writing some kernel, and you want to go in and toggle some of the indices. It's much easier to do it by hand than. So you always, I think, developers will want this ability to go in and unless we truly believe that everything is going away, it's like you really, really want the fine grained control.
Yeah. Yeah, that makes sense. Um, one thing that strikes me from what you were saying earlier about like observing that Copilot was really great, and there's all these, all this opportunity, and how do you kind of work with these AI models is, I think a lot of other people thought that at the same time. So, like, you had this idea that I think many people had, including a bunch of like YC companies and other products that I saw. And it seemed like Cursor emerged as kind of the winning one among these, right? So it seems like there's great product execution here, which I'm always really interested in. Like, do you have a sense for what you were doing differently than your competitors that made your product work so well? Was it like certain decisions, or was it like a process?
Why questions are always really hard. I don't know. It's very hard to tell
Totally.
exactly what we did right. I think it was a bunch of things where we always tried to push the ball as much as possible without being. We always wanted to be the most useful product at any moment in time. So like at the frontier, it's very easy to overpromise and underdeliver. And a lot of what we have tried to do is we didn't ship the agent until we were very confident it was something that was really useful. And we had probably done 3 agent prototypes before that we didn't ship because some version of the model would just lose track, and you could make something that was could help you in the short term, and really hurt what people think of as a reliable product in the long term. Maybe that is part of it. It was always, but then also I think we've been first to a lot of the inventions that people really like. So, um, more recently, the ability to jump to the next location that should be edited is something we've had for closer to 8 months, 10 months, a year, and we hopefully will release a much more upgraded version of it soon. That'll be like quite a bit better. And only recently, other people have tried to do that. So we've always tried to be like think of what's coming and at least have a prototype out as soon as we think it's something that's really useful. There's the tap to jump features. There's the apply features. Yeah. And we also we've done this at scale also. So I think that has benefited. Where, for example, for our custom tab model, we do something like 100 million requests a day, and quickly growing. I think part of doing it well has been able to do it reliably for lots and lots and lots of people.
Do you think that any of the data that you have or the feedback that you have from users is part of your success, or are you more making the decisions through
No,
your own experience?
the data has definitely been enormously useful. I think the feedback loops that people consider obvious are indeed extremely useful. You want to be the company that uh, feeds an extremely good product that everyone loves, and then that definitely helps in making the next version even better. It helps in small ways. It helps in training models. It helps in, yeah, where the small ways are, you understand how people are using your product, and what is the most important thing to ship at any moment, and then in big ways in like training models and improving just the core workflows. You can, for example, like technically speaking, one loop in the apply use case is uh, you're creating your first version of an apply that is quite a bit bigger, and you then deploy it for all users. You get lots and lots of data, and then you can distill a slightly smaller model that gets faster. The people use it even more, and you then distill an even smaller model, and you can like keep compressing the models down because you're sort of generating the data that allows you to do that. But also, yeah, it's this like feedback loop, and then some of the things get faster. So for now, up to like I don't know, 1,000 or 2,000 line file, apply feels effectively instant, and that's what we wanted to feel, right? Right? We wanted to feel like apply is this deterministic, they figured out some deterministic algorithm to like place the blocks, but that's not actually what's happening. It's a model that is actually rewriting the entire file, and a lot of a lot of the improvements have been making the model smaller. There's obviously improvements in just making the inference much faster uh, with doing these speculative edits. So yeah.
For something like the agents that you talked about, it like you had some iterations where it wasn't useful enough to ship. Like, how did you know that it wasn't good enough to ship? Like, how did you think about
I
that?
didn't use it on a daily basis. I think these things are really quite easy to figure out.
Hmm.
If you're coding 10 hours a day in Cursor, right? Like you boot up the editor, you're making the improvements, and you're seeing it on a daily basis. If the devs themselves don't use it every single day, it's probably not something that everyone else will want to use. I mean, there's obviously corner cases to this thing, where we're not the perfect coders, but a thing like an agent is such a general feature that if you're not using it, it's almost certainly not useful.
That actually leads me to another question I had, which is you and your co-founders have this background in sort of competitive coding, right? Like, does that do you think that's an advantage for you? Because I could imagine that that might sort of put you at sort of the forefront of like wanting to be efficient in coding, but I could also imagine that you might have idiosyncrasies in the way that you want to write code that might be different than your general user.
I think we're not only competitive coders. Like we did competitive math and code because that's sort of part of the background. It's always really hard to distinguish what part of your identity is the most important. But many of us had worked at sort of software companies before, Stripe and the like, and you had some idea that production coding was very different from. And then people had actually built products. So I think Michael had spent quite a bit of time building these high performance games, and we had done modeling work. So we had seen quite a wide variety of coding. So bringing back to like, does competitive programming really affect how you did coding on a day-to-day basis? Like, not really. It was just, yeah, I think we knew what engineering was. We were sort of doing day-to-day engineering, and you could see if the agent was helpful. And in this case, it was very clear that, for example, our early iterations were not really that useful. It was very slow. Uh, I mean, one of the most important things that has changed there is the length of the context windows that you can do on every single keystroke on every single request. Uh, when the model started out, you were sort of doing these 4K, 8K context windows, and even if the models, slightly supported them, the models were not very good at using the large context windows. And now that you can sort of easily do, as the cost curve has gone down for the language models, you can do requests on the order of like, mid hundreds of thousands, like, 50,000 tokens, 60,000 tokens, reliably. That has like enormously helped.
Hmm.
One intuition to have here is the model can't even feed your current file. Like it'll not be very useful, let alone like read the rest of your repository or do searches or lots of things that you expect a basic agent to be able to do. That wouldn't work if you're 8K tokens. 8K tokens, what can you even fit in there?
Right.
Uh,
Another interesting thing that you guys said in your interview with Lex Friedman is that you kind of wanted the experience of using a code editor to be fun, which I thought was kind of a cool idea, like a little bit surprising, right? It seems like such a utilitarian thing. It kind of reminded me that when I remember when I switched in Cursor from my default LM from Sonnet to O1, actually, I think I started coding a little less. Like I was actually having a lot less fun because there were like the latency was higher. It's kind of took me a little while to like realize that, but I actually I like for some reason Sonnet had lower latency and it made it just like a lot more fun. And I was like, you know what? I just need to go back to the the LM where I was like just enjoying like writing code. So I do actually kind of relate to what you're saying, but I'm kind of curious like how the idea of like a fun experience shows up in your utilitarian feeling application.
I think it just, I mean, there's always this sort of end metric, right? The end metric is how much we are enjoying using a model, and it's been very clear that we enjoy using Sonnet more than O1.
Mhm.
And part of it is uh, there's a few things. So one is I think Sonnet is extremely is even at scale like reliably quite fast. And I think we want to ship models that are even faster, that are better than Sonnet, that are much longer context windows, that could make edits reliably over a much larger set of your code base, for exactly the same reason, because it becomes much more fun. So it's in some sense it's this uh, hard to pin down feeling, but in some sense you know what really affects it. Like you will get bothered if you have to explain to the model again and again what you're doing, or you will get bothered if the model doesn't really understand that like you had some recently viewed file open and the model doesn't see it, and that's sort of annoying. It's just straight up annoying. So you can turn it into some methodical thing that you can like track down. Uh, but some of the inventions are just like, you know, wouldn't it be more fun if blah 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 happened? Like, wouldn't it be more fun if you were coding and the model would just once you started doing a refactor, it could just you could tab to the entire thing like 10 tabs. What would that take? And then once you think like, oh, 10 tabs would make me feel really really happy, you can then sort of reverse engineer the exact thing, like the modeling work that you would have to do. So like, what size of the model you want to train, how much time you want to spend sort of pre-training, post-training, and RLing the models to be able to consistently do the same behavior again and again. Uh, and you could another example, right? Concrete example is you could always overtrain the tab models to be annoying. Uh, so part of this, if you were to only worry about making sure that every single time it does the edit, you would over predict. Like sometimes you really want to like you're writing against some kernel, you want to spend some time thinking, and you don't want the tab model bothering you. And that's the thing you would only care about if you're making it fun and enjoyable, as opposed to something that like so something that's like obviously just always over predicting.
But this is a pretty subjective experience that you probably couldn't pull from user data. So, like, how do you work through that internally? Do you ever have like a difference of opinion with yourselves around what's the more fun
Yes.
approach?
Um, I think some of these transitions are subjective, but I think if you think it out, they're not always that controversial.
Interesting.
At the end of the day, you're trying it out. There's always some intuition where you might like over trigger in some direction, but for the most part, I think like if like there's not that much argument. Or is Sonnet more fun, or is O1 more fun? I mean, Sonnet is sort of arguably better, and hopefully there'll be like more models that are optimized towards sort of keeping you in the flow. I think you need a broad category, two categories of models. You need the category of models that is uh, RL towards being fast and super large context windows and just make edits across your entire code base and make you feel like you're breezing through things. And you want a category of models that is sort of trained for being extremely careful, for reviewing every single small thing before they make the edit. Maybe you do a bunch of research, they then make the edit in the background for you, like, and then come back to you with a PR. And in that case, the thing that will be fun is if they're more correct than not. And then fast is not the only thing that's fun. It's being correct, or how they write out, like how they prove to you that they're doing the right thing.
I guess as you kind of build a bigger brand and you build, trust with users like me, why are you even asking me what model I want to use? Like I'm sort of aware of the different models, but I would sort of trust you more to know what's going to be fun and useful for me. Like
Yeah,
why are you even
I think
exposing
you're
that?
kind of right. Yeah, I think you're kind of right. We've been part of building the trust was always showing exactly what we're using, and I think you're probably correct that we should have a default mode, and you should use the default and you should feel happy. But there's always, if you're the kind of person that wants a new mode and want to perfectly fine tune every single thing, you should be able to do that, and then there should be the simple defaulting. So there should be a release in a week or two that fixes all of this for you.
Oh, here's something I've been wondering about myself quite a bit. Like, do you think there are best practices in changing the structure of my own code base or the way that I should code to make your product work even better? Like, for example, we have one engineer that's been sort of letting the LM like put in notes inside the code base of like helpful things to kind of
I think
help it
that's like the
understand the code base.
one of the things that we've been sort of speculating about. We don't actually have a really correct solution there. But this idea of like maybe there should be a readme.ai.nd
Hmm.
in every folder, uh, with the idea being, at any point in time, if you ask changes around any folder, the model should be able to look up what's the nearest place where there's an architecture written down that it can uh, sort of on the technical side. The thing to understand is the models are much faster at reading tokens than humans, and like orders of magnitude faster than sort of ingesting these tokens. Uh, but humans have, for example, like some small things memorized. So there is obviously small differences between how we code, where the model is starting from scratch every time. So cursor tab in our code base is named CPP for being Copilot++, and uh, the model will always sort of needs to be reminded that whenever you're searching for something that says Copilot++ or something, what you actually really need to, or whenever I say cursor tab, you should actually search for Copilot++ or something like that. So there are these facts and rules that are quite important. How I don't want the default to be, so it would be better if everyone sort of changed their way of coding. I think the obviously better approach is we just figure it out. We should just spend all the time and energy we need, and all the compute we need to really nail down the architecture that you have. Like really figure out all the facts and rules. I don't know if I have any like interesting controversial ideas for how that should be done. Someone was joking that, maybe we should email you 10 rules in the morning and you'll just like yes and no on the 10 rules, and hopefully we'll build up a corpus over time. Like you want a system that allows you to add rules and then prune bad rules. Like sometimes there will be, like if you just ask the model to look at a PR and give you some rules, then sometimes it will come up with bad rules and you need a way of pruning them out. So like what is the minimal set of rules such that all your PRs become much easier? Does the model need to look at all of the rules? I mean, we're still sort of figuring it out, but I think there's something important at the core of this that is both in terms of like how humans would change and also in terms of what we should change just to like make the defaults much better. Because not every single person will change.
Of course. But for example, like, do you think smaller file sizes are better because the model can more easily like navigate the code hierarchy, or do you think that creates complexity?
There's always some trade-off. So the funny joke is that like sometimes people will sort of keep adding to the same file more and more until the model can't edit it anymore, and then you just ask the model to refactor that file for you because you're just like sort of in Cursor terminology, composing the file more and more. And it seems pretty clear to me that there is obviously some advantage of the model seeing all the context relevant to the current task in the same file, and also that uh, for future tasks, it'll be easier if the file was smaller. I think infrastructure-wise, we will also make it possible for you to sync all of these files to a remote server. So like we will have a copy, like a big enough copy of your code base at some point. So right now we're extremely privacy conscious, and that means like we try to make sure that we never store any code past the life of your request. Ideally, in the future, we can store at least some part of it in a private way that allows the model to very quickly do reliable edits. So it shouldn't have to sort of make these round trips for making every single small edit, and that feels quite bad.
Mm. What else? So you were telling me that you run infrastructure. Also, can you talk about like what the interesting infrastructure trade-offs are at Cursor?
We build lots of different pieces of infra. There's sort of the traditional company infrastructure, but then there's also a lot of things. The one that we've been sort of very public about is our indexing infrastructure. That we spent a lot of time optimizing and running at quite enormous scales, like billions of files per day kind of infrastructure. And for that, we run our own inference. So for all the models that sort of embed your files, we run an enormous amount of just these like really large pipelines. So like if you're some big company and you have like 400,000 files or 500,000 files, you want the ability to, while the user is coding, effectively feel like it's being instantly synced across to the server, while the model is using the embeddings to like search the code base or edit the code base, et cetera, et cetera. So scaling that has been quite a challenge, and I think there's been this sort of broad category of databases that are being built on top of S3, and we're like a big believer in this approach of you should build your database slash store of like there like the I don't think there's like a clear like the usual term is sort of separation of storage and compute or disaggregated storage databases, but so the classic example of this is we use turbo buffer. The turbo buffer stores most of the vectors on an S3 sort of path, and then they have a write ahead log, and you sort of write to this write ahead log. The write ahead, when there's some compaction process that compacts the write ahead log back into the database. And then there's sort of new challenges we've been dealing with this indexing infrastructure. So we've been thinking about, is there a way in which you can support shared code bases? So if all the people at weights and biases have a really big code base, hopefully in the future, you will be able to spin up background models editing your code base. And so, we want thousands, if not tens of thousands of sort of clients that are connecting to that code base, and we don't want to have 10,000 copies of the weights and biases code base for most of which are not being utilized. So can we have a shared trunk, and then every single person can have their sort of branch off that trunk? That sort of architecture is still, we're working on it. It's not exactly easy to do because, how do you easily branch this vector database? At the end of the day, you want to be able to query both the trunk and your section and merge them in a way that you still get the correct top K chunks. That's not trivial.
So when I fire up Cursor, it's like quietly indexing all the files that are in my project.
So we try to, yes, exactly. So when you fire up Cursor, it quietly indexes every single thing, whether as long as you both allow us, and if it's default turned on. One really popular Cursor use case is like you open up a GitHub repo, you clone it, and then you fire up Cursor in that GitHub repo, and now you can quickly ask questions about it. And we try our best to like make it effectively instant to you index these really, really large code bases. There's still obviously if you clone like LLVM, which is 120,000 files, like that will take us a bit longer. Uh, but so, for example, an interesting infrastructure question for the listeners or whoever is like pondering about is like, should you how should you allocate these token capacity? So we at any point in time have a fixed number of GPUs, which means we have a fixed amount of token capacity. Should you be you want to index LVM or weights and biases, and that's a really large code base. And then there's a bunch of people that have a number of small code bases. Should the number of small code bases always be allowed to go through and you should be slow, or should you take a lot of the capacity in the beginning and everyone else gets like a smaller chunk in the hope that you shouldn't get a really bad experience? And that kind of question is still sort of hard to run scale.
Well, how do you think about
So that
that?
everyone currently we try to like keep both sides like relatively happy. So there's you can boost up your capacity up until max thing, but I'm still like looking for better answers. I think there's probably we haven't spent like that much time thinking about it, but hopefully there's like a really good answer to like how do you make people happy. Um, there's no serverless GPUs, right? Like there's no great serverless option because at the end of the day, the amount of compute we're spending is still fixed. Lucas indexes the amount of compute is just like the amount of compute you index your code base plus the amount of compute for like every single other person that we're indexing. So in an ideal world, that'd be this phenomenal serverless thing where you could boost up your capacity and then people can use that capacity and then we could boost it down again, which is what would happen in CPU land. And that sort of infra has not been built for GPU land.
Is indexing the main thing that your GPUs are doing? Because you're also running lots of models too. Like how do you
Yeah.
trade
So
that
we
up?
run the tab model. Like indexing is a very small percentage of our GPUs. I mean, we run the tab models, and hopefully we'll be running much larger models in the future. And yeah, they far and away dominate most of the compute cost
I see. So the
for
model
indexing.
running the tab
Yeah,
model is the main thing.
yeah. So tab model is like hundreds of millions of calls per day. Uh, the big models we're running have thousands of requests every few. Okay, so without going into detail, thousands of requests going on, and so we're scaling up these models as fast as we can, and they definitely take up far more compute. It kind of makes sense. Also, they're like larger. Uh, one intuition to have is again, you're doing tens of thousands of tokens of inference per keystroke per person, which is both really cool and also really scary if you're running the infra forest. Like obviously caching really helps, but it's still scarier than running a server.
Has there been any surprises as you've like scaled up this ML infrastructure? Like, I mean, you've got to be one of the fastest scaling, you know, ML companies ever. Like, have there been any like kind of pitfalls or like, I don't know, like what's that experience been like? Smooth?
There have been glitches, but I think like again, the team is really really talented, and we've sort of gotten over it.
Nice. Um, what about, I mean, we're talking like, maybe 2 weeks after DeepSeek came out, and then obviously caused investors to like change their mind about NVIDIA stock. Did it like update your
It's
beliefs
like
at all?
really weird to me because I think we're like both on the Lex pod, but also before that, we've been pretty public about using DeepSeek in many ways. And we used to use their 1.5 series models and then switched over to their V2 series model. So it was this like big shock to personally to me that like everyone was sort of like going hoo-ha, like this is some new thing. And no, they've been producing phenomenal work for a while. Their models, like I used to joke, like they were one of the 3 or 4 or 5 companies that you would trust to like produce good models, where like the numbers wouldn't feel like they were juiced up in a way that there were certain models that felt like their numbers had been a little bit too juiced up. Like by juiced up, I mean like they were really high for evaluations, but then if you use the model in practice, you would never like using the model. It's just very specific to sort of the evaluations. But DeepSeek, I felt like was very honest about things and has been producing really good models. So we've been running the DeepSeek V2 model for 8 or 10 months now, probably 12 months, something like that, on our own inference. And that's the model we've scaled up to hundreds of millions of calls.
Interesting. How did you choose it? Was it like just the best?
Oh, we knew they were, yeah, it was the best. It was the best. They had been producing extremely good open code models. We have our own sort of post training stack and with URL and stuff, but for just picking a really well pre-trained base, DeepSeek does a phenomenal job. The data they train on is really good, and the model is both quite knowledgeable, quite smart, and also quite cheap to run for the tab in particular. And I think in general, I'm really excited about DeepSeek V3. I think DeepSeek V3 is actually a really well pre-trained base for large models, and I suspect it will be very useful for making these custom applications.
So, I mean, you've obviously launched, like agents, and it's pretty cool, but it's also kind of contained in like how many iteration steps the agent will do and things like that. Like, where do you see kind of agents, going in the near term? I mean, like obviously inference is getting a lot cheaper. It seems like you could go much broader if you wanted to. Like what are you
I think we're
thinking?
super focused on it. I think as people have been getting better at doing RL, the model have been getting better at both thinking and also being extremely coherent. So I think one of the things that is talked about less is how coherent the models have gotten over producing tens of thousands of tokens of output, which they were not before. I think they would sort of go into delusional mode after a couple thousand tokens immediately. And now they've gone quite a bit more coherent. And that comes from doing RL and really good post training. And I think agents were bottlenecked by that particular aspect of coherency. Uh, One of the things that makes the Sonnet experience really magical for using in an agent is that it's so coherent over such a long period of time, like over tens of tool calls. And I suspect as the tasks get harder and harder, you would need to be coherent over hundreds, if not thousands, of tool calls and working on it.
One of the things that
Like
we
I think generally, like again, like back to the mission of the company. The mission of the company is sort of what is the we want to automate as much of coding as possible, and while still having the developer in the front seat. And automating coding in the short term involves, you know, allowing developers to just like in the cases where they want to sit back and let the model code doing that, but in the cases where they want to drive the editor to like make code, like I don't know, you're doing Bayesian biases and you want to like switch your gRPC thing to some other TLS package in Rust, like you should just be able to tell the model like I want to switch my gRPC thing to use Rust TLS instead of something else, and the model should just get it and be able to make these large scale code base flight changes. And that requires the model to be have some agent type things, because you're never going to sit down and write out exactly the spec of your code base. The thing that the agent really helps with is you don't have to sit down and explain like, we are 1DB, we make this, we have a backend that is written in Rust and Go. The Rust hooks up to Go in this way, and for our library we use this, and the model should just go and figure it out.
My own experience of playing with agents, which is much diminished compared to yours, is that, when it breaks is kind of the challenge to debug. Like, have you built any systems internally for just even looking at like, okay, what is the agent doing? Like, why did it get in a weird loop here? Like, what's happening? Like, how do you visualize that?
We're building our own infra for it for now. I suspect that there will be phenomenal products in the future that will make this much easier. For now, we same thing with building prompts. So we use this internal library called Preempt. And the way we built Preempt was it was well suited to our own needs at the time. And I think for the same sort of agent infrastructure, we'll be building our own infrastructure in the short term. And I suspect in the long term there will be somewhat phenomenal, dev tools that will come up to make it much easier to both inspect the chains, be able to stop at any point and restart the chains, be able to debug them in production when something weird goes wrong, all sorts of things that you would need to be able to run like a production system at scale.
Is the agent evaluation like more also like it sounds like it's more of a vibes based approach than like specific
So
metrics
currently,
or
it's pretty wise based. I suspect it'll be wise based in the short term and become as we get better at shipping these, it'll become more and more sort of um, daily metrics, and you'll be much more operational with it.
Hmm. When you look at like something like a Devon or like these sort of like completely automated, like no programmer like approaches, do you view that as like competitive or interesting or like what is
I
your
think they're
take there?
interesting, and in the medium term, if you can actually take your hands off and let the model drive your entire editor, or let the model drive the entire editing process, I am totally open to it.
Hmm.
Uh, but in the case where it's like not really useful and kind of boring and not really that fun, like we just wait.
We just what? Just wait.
We just wait until it gets good enough. Like we keep training the models, and at some point it will get good enough, and then it will be really fun to use. I think in general, over a 1 to 2 year time frame, I expect that the way people will code will change.
Okay.
And I don't think people, I think in the short term, that seems really scary, but I think it'll be this gradual process, and it'll be extremely natural to everyone coming in. That the way coding is changing, I think, like, for example, the change from not having a copilot to a copilot was extremely natural in retrospect. Like, it was not something that was like scary to anyone, right? It was this thing that like sort of predicted the other thought, and you were like, wow, this is phenomenal. And you just sort of started using it. And then the change from going from sort of this copilot to this um, foreground agent interface where the model does edits across multiple different files, and you're like, oh, I want to switch this to use Rust TLS, and I want to, make sure that you always use HTTP2 and blah, 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 blah. Like the model gets it and it reads all the files and it makes the changes, and you can immediately review the changes very quickly and tell they're correct. And that was also pretty natural. I don't think there was any way in the middle where like people felt like disoriented. And I think the sort of going to background things, it'll be all these things are always, more gradual than one would expect. You would have expected in 2020 that, like, if I said the way you'll be coding is you'll sort of start talking to the computer and it'll make changes to random files, and you'd be like kind of freaked out. You'd think, oh, it's going to add all these bugs. It's going to be impossible to review. Like, I really enjoy coding. Why the fuck am I doing this? That like all these things would have seemed scary. And yet, 5 years in, 4 years into the language model journey of products, like things feel quite natural. So like 2021 is Copilot, 2025 we're in now, and at any point in time, making the change has not felt very disoriented. Which,
It
like,
well,
maybe in one step it would have, but right now it's not really that disorienting.
well, it feels like a lot of fun to me. I mean, like it's like I guess like when I like connect the dots from like 2020 to now, I'm
It's like
like,
it's gotten better. It's like it's gotten better, right? It's like it's
yeah,
not even
well, it's
gotten like
I guess where like I'm going is like, when I look a few years out, I have no idea, but it's hard not to see that like a world where you wouldn't really be doing anything that looks like programming a few years out, right? Or
yeah,
where do you
like more people will be coding, more people will be making much more difficult things, like things that are considered much more difficult, be it lower level things, be it uh, larger projects, even for their side projects. I think people are usually very conservative in their side projects because they're like, I probably won't have that much time. I think people will get much less conservative with these side projects. I'm generally just extremely optimistic in the medium term.
Yeah, yeah. Do you feel like at all like I mean, I guess first of all, like I mean, don't you think it's a totally different world where everyone can do these like monster side projects easily? Like that seems like software is a very different feeling. Even like doing a software company seems like it might be hard to like, have like a protected advantage as much, right? When it's easy to build this stuff.
I I I can't philosophize over that. I think I'm not really scared of people having medium sized. I tend to think of these things as like experimentation becomes uh, much more natural. I think a lot of the things that large changes are usually scary at companies because a large change requires changing so many pieces and changes so much time that you want to plan out everything up front. And then planning is really hard because you can't really foresee like how your production system will look if you do X, Y, Z. And everything becomes much more scary. And then you add more meetings and it becomes more formal. And then everything just becomes worse and worse over time. And I understand it, right? If you're doing multi-year database transition, boy, do you want to plan out every single small detail. And then you want to argue over every single small detail. But if you can start sort of prototyping these things really quickly, maybe it becomes less talking, more coding. You have much cleaner, concrete artifacts. Um, if you're in PyTorch and you want to do a small API change in PyTorch, it'll take a year. You probably want to debate out the hell out of it. If you're in PyTorch and you can have a prototype in 3 days, uh, maybe you should just argue over the prototype now.
Is that how you do things at Cursor?
Um, Hopefully more and more so, yeah. I mean, there's still things that are scary, but definitely, I think I found myself thinking it's just much better to argue over the code. I suspect that change will continue.
Awesome. Well, I guess one final question, if
Yeah.
something comes to mind, when you think if you were sort of outside of Cursor and kind of like fresh eyes into this, kind of world of AI applications and LLMs that kind of working for so many different things, is there something else that kind of excites you that you wish you had time to think about?
Personally, for me, I've always wanted sort of like a really good reading experience. Both I like to spend my time sort of free time either reading or spending time even reading code bases. I think it's sort of this underrated aspect of coding that like all of us produce these some of these artifacts that we poured our many years of our life into. Uh, Redis, someone has poured their life into Redis, and I really want to go read and understand Redis. What were the hard decisions? What were the easy decisions? Uh, and I think both for reading books, for reading papers, and for reading code bases, we haven't discovered the final optimal AI tool. I think hopefully Cursor will contribute to at least reading code bases, but maybe someone makes it easier to read books or to read papers. I'll be really happy. Like reading papers is still like quite an arduous process. I mean, PDF viewers, I don't love the current PDF viewer. Still, like you click a thing and it'll jump you to the final thing. It feels like a lot more primitive than it should be. And I've recently been reading papers by just pasting them into one of these sort of chat apps, and uh, things are getting better. I think in general, like it feels like there's a lot of low hanging fruit in lots of different areas of life.
Okay, I got to ask, do you have any, what are your top recommended reading code bases?
Well, so as I just mentioned, Redis is quite good if you haven't read it. It's relatively small, and still it's still quite fun. Probably that's the one I'd most recommend people because it's a thing that is used by everyone, and uh, it's just really, really well written. SQLite for sure. Also, if you haven't read SQLite,
Yeah.
um, again, very well written. It's this coherent document by a very small number of people. And then I think mostly I just recommend like software that you use. You should try to go read the software that you use. I mean, some things are harder, but like I don't know. If you're a fan of Ghosty the terminal, maybe you should go spend a weekend trying to read Ghosty. Or like if you're a fan of PyTorch, maybe you should go look into why PyTorch does what it does. I think there's a lot of choices that you can sort of criticize on the outside, and people underappreciate the tremendous amount of work that people say on the PyTorch team have put in to make PyTorch like really, really easy for you to use. And this like magical experience where all the just sort of gradients flow naturally that has taken like many tens of thousands of engineering hours. I don't know if it's in the hundreds of thousands or the millions, but it's like a lot of engineering hours.
Interesting. Well, thank you so much.
Yeah.
I really appreciate your time. Thanks so much for listening to this episode of Gradient Descent. Please stay tuned for future episodes.